So this is our next situation. We have a 3-meter column and pinned at both ends. So we have the actual load loaded to it is 190 kilonewton. The column is made up of two angles, no? Dalawang angles ang ginamit of an equal leg with long leg back to back and separated by a gusset plate whose thickness is 11 millimeters. So we use A36 steel which has a yield stress of 248 megapascals and a modulus of elasticity of 200,000 megapascals. So meron tayong tatlong section na i-consider. Kumbaga ito na yung mga candidate sections natin. Kasi ito yung mga radius of gyration nila and the area in square meters. Take note of this, square meters. So ngayon, which of the section gives the largest allowable compressive stress? Which of the section gives the smallest? And which is the most economical section? Okay? So let's solve this one. So, titest natin lahat ng sections. We will solve for each section. Ano yung kanilang mga allowable. Then, tsaka natin sasagutin yung questions na to. So, first, we have dalawang angle with a dimension of 125 times 75 and the thickness is 12. So, long leg back to back yung kanilang. Okay. So, this is how we solve since yung compression member daw natin is pinned. Sabi ba dito ay pinned o pinned at both ends. Pinned at both ends. Therefore, your end fixicity factor is 1. Nasa table. L is the length of your column. Let's see ha, kasi di ba kanina 12 meters yung columns natin. So parang long column talaga. How about this one? 3 meters lang. So the radius of gyration of this is 16. Okay. So we have Ry and Rx. So there's a note that use the least value of R in order for us to have a higher value of slenderness ratio or the critical slenderness ratio. So we are using the least between Rx and Ry. So we can have, therefore, if this is 16, our effective slenderness ratio is 187.5. Therefore, next we solve for your compression index. And your compression index should be equal for all sections kasi ito ay according to the property or given. Ito given naman to and this is given. And yeah, pi squared is also constant to us. So your compression index is 126.169. If we compare that to your slenderness ratio, your column is said to be a long column. And then, we solve for the stress. Given the formula of 12 pi squared E over 23 multiplied to the square of the effective slenderness ratio. So, ipapasok na natin siya sa formula na to, yung mga given, and solve values. And it will give us, this is for 2L125, no? 29.29294. Okay, so ito ang FA niya. Lagay natin dito na another table. Ito ay 29.294. How about yung double angle natin with the dimension of 50 by 90 by 12? Or sorry, by 10. Ken, we will solve for this one. And we use 19.5. Now, ito yung list between the two radius of gyration, and we can have the value of the slenderness ratio as 158.8465. And again, pareho lang naman yung compression index. And when we compare, it is again a long column. So same procedure, and your actual stress or your, yes, actual stress is 43.512. 43.512. Okay, the last section is one double angle with a dimension of 150 by 90 by thickness of 12. Okay. This one. So, yung ating radius of gyration is much larger. If we solve the slenderness ratio, we can have 119.522 compared to our compression index. And this is a short column. So we will use the other formula. So we will solve, this is the value of KL over R, na-solve na natin yan, and the CC, na-solve na natin yan. So we will have the factor of safety. This is your factor of safety. And then we solve for the FA, and your FA is 71.359. Okay, so this, the largest compressive stress is 71.359. And while the section with the least allowable compressive stress is that the first one with 29.294 megapascal. But how do we solve for the most economical section? We select the lightest section, lightest weight, the smallest dimension that can resist, or the lightest section that can resist the given load. So for our problem, ang given sa atin, we have 190 kilonewton. That's the allowable compressive stress for each section is given. Ayan yung mga allowable compressive stress. Now, we have your areas given dun sa table. Ito yon yung mga areas given to. No? So, let's see kung kaya ba natin i-resist to. Dapat yung allowable or capacity ng section natin is greater than dun sa ilo-load natin para ma-resist natin yung 190. Let's try the first section. If we are solving to the capacity force, that is your stress multiplied to the area. Okay, so if you have your 29.294 megapascal multiplied to the area of 0.00454 square meters, and we will solve for, kailangan convert natin to have the same units. So we have P equal to your 132.995 kilonewton. And this is not safe because this is less than your 190 required load. No? So pag nag-load tayo ng 190, ang capacity lang pala niya is 132, it would fail. Mag-fail yung section natin. Okay, so how about the other one? Ito naman yung area niya. So this one, same procedure pa rin, no? We have 201, no? 201.561. So it is greater, no? Malaki na siya kaysa dun sa ating required load na 190 kilonewton. Malaki na siya. How about this one? Okay, it is also much larger than your required load. So, meron tayong dalawang candidate, final candidate na eliminate na natin the first one. So, dalawa na yung section natin, the 150 by 90 by 10 and by 12. Ngayon, what would be the most economical? So, in this is the explanation. So, since yung section natin, pareho sila ng dimension eh. But nagkakaiba lang sila dito sa thickness. Magkaiba sila ng thickness. So, the most economical for us is that one with a 10 millimeter thickness, no? Kasi it is lighter also than to double angle na 150 by 90 by 12. Obviously, because mas manipis yung section. So, the weight of the double angle are not stated, but since the two differs in thickness, it is safe for us to assume that possible natin itong gamitin. Okay? So, yeah. Okay. Actually, di given kasi sa atin yung weight ng ating section. But if the weight is given, there could be changes in our answer. Kasi for example, yung isa, di ba, 201. So, sobrang lapit na lang sa 190. And hindi stated sa atin yung weight ng section. And the self-weight of the column ay dadalhin pa rin ni column. So, dapat i-add pa na rin self-weight. It could be safe to practically carry the load. Pero we don't know kasi what is the specific weight o self-weight na madadagdag pa sa madadagdag pa dito sa dadalhin ng ating column. Pero the question for us is the safest to resist the given load of 190 kilo Newton. And that is double angle 150 by 90 by 10. So, ganun lang yung compression nyo. Okay. So, for your trusses, diba, for example, may truss nga kayo. Na-identify nyo na which section is going to be a compression and alin yung hindi. Alin yung tension, alin yung compression. So, for example, this one is a compression. Compression yan. So, ang gagawin nyo lang naman, kailangan alam nyo yung length. Then, dapat alam nyo yung force. Kasi, pag sinolve nyo to, graphical method or method of joints and method of members, malalaman nyo ano yung force na dala-dala nito. And masasolve nyo na. Then, from that, what you will find is your required radius of gyration. Then, pag nasolve nyo yung radius of gyration, hahanapin nyo dun sa economic section natin, what is the smallest radius of gyration that would, itetest nyo lang siya, i-run back nyo siya, i-back substitution nyo naman siya, and you shall solve for the, if it could carry the actual load na iloload sa kanya. So, that is how we do your column compression analysis. Okay? So, kahit na, for example, again kahit na, for example, this is 2 meters lang, yung width niyan, it could also be a long column as long as maliit yung ating radius of gyration. So, factor din yun hindi dahil malaki yung value ng ating dimension, justifiable na siya na long column siya. So, gano'n. So, that's it.